So your product is so easy.
Sorry?
The product is so easy, you only need 5 minutes to
Yeah, it's very simple.
Was machst du deinen ersten Vortrag schon hinter dir? Jo. Was ist das?
3 videos.
Okay, I think we'll get cracking now. We look like we've got enough people. So thank you very much for coming into this session. My name is Paul Wright and I'm an EMEA SE engineer working for Whiptail. Basically, I've titled this session Transforming Application and User Experience, Removing the Cost and Performance Bottleneck from Your IT Stack. I think it's quite catchy. I think
they'll all be coming in now.
Okay.
Might want to start again.
That's fine. I was just commenting on how catchy the title of my session is, really. I've gone with a very simple title. Basically, our product is a very transformative product, and it allows you to do things in a very different way than you might have done before, and it allows you to take advantage of some, unique technology to really speed up some of your projects. So I'm going to kind of introduce you to the company. I'm going to talk about some trends and challenges that are out there in the industry. I'm going to review the product shortly, and I'm going to have some time for questions and answers. And we're around all weekend. It's myself, Paul Wright. Oliver Cheel, who's just sat there, is a sales guy, so stay away from him. No, I'm joking. And Mike Beaver is our EMEA product management team. He is the man. So we should be able to have all the answers here and we should be able to help you. We've got a really in-depth session tomorrow, and on Sunday we're doing a very short 10 or 15 minute pitch, which Ollie's going to do, talking about how our product fits into the business and how our product makes sense from a business point of view, which if you guys are talking to your clients about our product might be really helpful. So Whiptail has been around actually for quite a long time. We're a bit of an odd startup in that we actually had revenue and did business before we took any public funding, or private funding even. What that means is that we've got customers who have our product who've been in production for 3.5 years, and specifically our company comes from the Citrix VDI space. So our company comes from people who were in your situation trying to deploy VDI projects and were failing because of storage cost and because of storage complexity. So this is specifically where our company comes from. We have customers who buy us for database workloads, for lots of different workloads, but clearly, when you start, well, actually not clearly, I haven't told you anything yet, but we're very suitable for VDI when it comes down to it. And the reason for this is that we won't wait for data anymore. If you take your customers, and your customers are generally people who sit in offices, they're working on their laptops, they want their service from their company to be the same as what they get from Amazon, from Google, from iTunes, from all of these places, yeah? So if they log onto their laptop and it takes them 20 minutes to go onto their laptop, or to 20 minutes to open their laptop, or it takes them 10 minutes to sync up their emails, they don't like that. They want to get the same service they get from the consumer outlets that they see, yeah? And this is what this slide is talking about, basically saying that people will abandon web pages if they don't arrive within 4 seconds. People will sometimes never return to the site if it doesn't work. So if you're a business and you're putting out some sort of internal service for your customers, who are your staff, or your external customers, if your customers, whether they be internal or external, if they get, to be quite blunt, if they get a crap service from you, the likelihood is they're never going to use that application again. Even if that application is important for their job, if it doesn't work for them and it's rubbish, they ain't going to go back, yeah? So, we hear a lot of things about big data. Who wants to shoot me because I've said the words big data? Yeah, thank you very much, that sounds good. So, big data, in my opinion, is like one of those really annoying words that probably someone's boss has said, we want to do big data, and it's one of those things like Ollie and me were talking earlier on and saying that basically when you go and speak to CIOs, when high-level people go and speak to CIOs, they use a load of jargon, and then that jargon kind of filters down to us a lot, and we've actually got to kind of make some sort of thing that fits in with the jargon, yeah? in my opinion, what big data means, it means that if you're an IT manager, or if you're or anywhere in the IT layer of actually managing the hardware, managing the software, managing the products you're creating for your customers, what big data means is that there's a hell of a lot more data than there was 10 years ago. It's quite simple, yeah? The likelihood is, per staff member, per user of each company, per customer of each company, we are holding more data than ever before, and the customers want more and more access to that data, yeah? So what that creates is a space where you have a lot more physical terabytes of data to store in your data center, because you're storing more data for everybody who has interactions with you. And it creates a lot of I/O, because more and more of the people that are out there, whether they be internal customers or external customers, whatever, they have processes and they have applications that they're using which access more and more of that data, and they manipulate more and more of that data. Does that make sense? And what that does is it creates two things. Sometimes size does matter, it turns out. It creates two things. And the first thing it creates is bulk data. So if you look at typical companies, schools, universities, public sector elements, they're going to be holding vastly bigger sets of data than they were before, yeah? But the other thing that it creates is it creates a really big requirement for things like velocity. And velocity is a very interesting thing when you come and talk about virtual desktops, and you talk about trading systems. You might be talking about, CRM, customer record systems, where the customers are using some sort of process that comes in and interacts directly with data. And that's where we're really focused. We're not focused on the volume capacity, because actually, if you look at the traditional hard drive market, if you look at the traditional arrays you can buy from, Isilon file systems, all these kind of products, they are great for big data volume. But actually, big data velocity, where you get a very big collection of users now accessing some sort of service in the data center, there's not a lot of products around that. Oopsie. So, what does that mean? What it means is that there are requirements out there that require high amount of write and read bandwidth. So lots and lots of writes, lots and lots of reads. And this is something that is very expensive and complicated to do with traditional disk systems. And they have some low requirements, which are latency and cost per transaction. So you want something that does very low latency and has a very low cost per transaction. Now normally in this sort of presentation, when I do it to a more generic audience, I guess, I'm going to be talking about lots of applications and lots of different places in the data center where this might be a requirement. But very specifically, because this is a virtualization session, it's very clear to me that if you look at virtualization as a tool, virtual images, whether they be desktops or virtual machines, and virtual machines maybe for some high-end uses like SAP, Oracle, etc., you can create a very dense amount of I/O requirement with virtual machines. Yeah. And actually, if you typically look at the arrays that you're putting your virtual machine file systems on, you're running your machines from, you can often get a very low utilization from those boxes. So you're buying a lot of terabytes in disk, but you're getting a low utilization. Sorry about walking backwards and forwards. It's a big problem to have in life. So I guess what we're trying to say is that if you're currently in a situation where you're buying for a requirement that has a high requirement in terms of performance, in terms of I/O, in terms of latency being low, you can end up spending a lot of money on a traditional disk system. And what we're trying to say is that if you look at the middle bit here, this is a bit of an eye test, but I'm going to talk about it anyway, so don't worry about the slides quite so much. If you talk about the middle bit here, what we're trying to say is that if you have to invest in disk and you run disk at very low utilization, which some of these big data requirements create, the cost is very high. Because you have racks and racks of equipment, and you have to keep adding and adding and adding exponentially more disk to give yourself the performance you need. This is especially true, as I said, in virtual machine environments, especially true in virtual desktop environments. Yeah? When you start to scale out virtual desktops, you just have to add spindle after spindle after spindle, and you have to crank on that requirement. And we see out in the field lots and lots of virtual desktop deployments that get stuck because the initial amount of disk that was purchased was just not enough to power the situation. On the left-hand side, would it not be sensible to develop a product that had a better cost per I/O and a better cost per performance block, rather than being costed per terabyte, costed per space, if we had something that was costed per I/O? So, hang on, let me get back. So, there's a couple of solutions on the marketplace for this. You've got your traditional high-capacity array. So a high-capacity array might be something from HP with 3PAR, NetApp, EMC VMAX, EMC VNX, those kind of products. And these products have a lot of capacity, and you can add some performance, you can have quite a lot of cache at the front of them. But in reality, with these high-capacity arrays, you end up investing a lot of money and you still don't have that performance. So you might have a 10 or 20 or 30 terabyte data set, but you have to buy 100, 200, 300 terabytes of disk. It's 4 or 5 cabinets, it's a lot of power, and it still doesn't have the performance to really drive a virtual environment. You get hybrid arrays. So hybrid arrays are basically going to have a little bit of disk and a little bit of SSD in them, so they're going to have a bit of a mixture of both. But again, a really big challenge of these devices is that you're making a compromise. You're saying that 40% is going to be SSD, but actually all my data is going to be sat on hard drives. So there's still a chance that that data, and when that request comes in, that it will be on disk, and it needs to be written back to disk. So it's not proven, it's not constantly going to be that high performance. There's also PCI Express cards, and I'd include products like, have anyone here heard of Atlantis? Does anyone know what Atlantis is? Is this the Atlantis SE? No, I'm joking. Oh, yeah. He is. Okay, great. So I would include PCI Express cards. I'd probably put Atlantis in there. And these are server-based solutions where you put in something into the server that gives you an acceleration. Yeah. And that gives you an acceleration onto the back end. So you might have a situation where you have a high capacity array in the back, or DAS, and you put something like a Fusion card or an Atlantis piece of software here. Yeah?
So, well...
You're smiling at me now.
No, it's your presentation, mate. I don't want to derail you, so...
Yeah. That's cool. So, basically, these three are options. Now, obviously, I'm placing us as a different option. And what we have developed is we've developed a box which is a endpoint storage array. So this is a replacement for whatever storage array you're currently using today for this specific high performance opportunity. So it has the enterprise features, it has replication, it has resilience, it has standard connectivity like iSCSI, NFS, fiber channel, InfiniBand. So it's a standards-based array that you can use and you can share the data. So you can have a VM, you can have your VMware or your Zen or your Red Hat cluster. The cluster works fine, you've got nothing in the servers complicating that. You have a shared array underneath it. You can replicate the data from site to site, so if you did want to put something like, if you're running stateless VDI, then you probably won't worry about replicating from site to site. But if you were running something that had a state in it like an Oracle database or an SAP database, etc., you could actually replicate that from site to site. And it's scalable, so you can start off at a few terabytes and you can go right up to 72 terabytes at the moment, and we believe that will grow. So we are a high performance array which is optimized for very high I/O from disk, very low latency, so it's a endpoint solution. Cool. Oh, I need to go forward. Sorry?
Just Logitech.
Oh yeah, no, I probably pressed the wrong button, knowing me. Right. So, at its most basic point, our product starts off at a 2U box. It's very simple. 2U, very high I/O. So, for example, we can do 250,000 writes at 4K with this box. What that means is that we've got customers in the field who are running 500, 1,000, 2,000 VDI images from a 2U box. In terms of the amount of disks this could potentially replace, if you were to do this, if you wanted to do this amount of performance with a traditional disk array like a 3-part, you'd need well over a rack of equipment to do it. Whereas we can do it in 180 watts, 2U, very simple.
I disagree with that.
Yeah?
Well, 3-part, you just put SSD in, just like you do with your product.
Okay, so the big challenge you get with things like SSD in the traditional arrays is that they don't provide the level of performance that we provide, because it's the way they write to the SSD is unmanaged. So we manage how we write to SSD.
But it's not going to give you racks of disk. So 3-part, I also wouldn't describe 3-part's traditional storage either.
Okay.
Because they're in the same boat as compellent. So they're going to do dynamic data tiering. So they're going to have SSD at the front, and they're admittedly going to have slow disk at the back. But they're not going to have, what you're doing is not going to replace racks and racks of 3-part, because the 3-part solution would also have a load of SSD at the top.
Okay.
Admittedly, it would replace racks and racks of what would be a traditional storage solution. It hasn't got dynamic tiering, but 3-part's probably the wrong choice, I would suggest, to compare yourselves against.
I think the thing that I'm trying to say, I guess, is that with these kind of traditional arrays, you have to buy it, and it comes in a rack, and it goes into your data center, and it's a sealed rack unit. Whereas ours, we can simply just, I've got a customer who's running 1,000 VDI infrastructure. They've literally got a HP Blade system with that sat on top.
Yeah, don't get me wrong, this stuff's great, but comparing against replacing 3-part's probably the wrong comparison. I would compare it against a traditional EMC center, for example, and absolutely we're on the right track.
Okay. They're all the, to be fair, if you look at EMC VNX and you look at NetApp, they all have SSD options, so they're all very similar in what they can do. So this box very simply connects over all the open interfaces I described, and is very, it's very easy to integrate into your environment. Generally, I've done probably 4 or 5. I've only been at Whiptail for like 3-4 months. Before that, I was actually at Brocade/EMC. So basically, I've probably done 4 or 5 installs of this sort of size box so far. And generally, it's like we're on site for 2 hours. Very simple. Goes in, you connect everything up, and you create the LUNs very quickly. So really simple box for VDI to go in. In Europe, we have pretty much, our largest customer in Europe is about 25,000 seats, and basically they're running on a stack of these. Yes?
I guess they all do, your customers do non-persistent VDI?
Yeah.
Because for persistent VDI it would be interesting too, but there you would need much more capacity, or something like Atlantis or a similar deduplication solution. Is there any recommendation of how to do persistent VDI with?
So reason, this box here is a single unit, as in it's a box. So I would never recommend to run something that's like non-persistent on it, like a SAP database or a non-persistent desktop.
Yeah.
But we have another product, which I'll talk about in a minute, which I would recommend for persistent.
Is it more expensive?
It's about the same, it's a similar price per terabyte, it's a little bit more expensive.
Okay. Because this is already not cheap.
Well, it depends if you compare it against the rack full of disks, isn't it?
But what is interesting is what is the expected life cycle of these boxes? Because I have a lot of customers who are hesitant of buying stuff like this because they don't know if it will be broken in 2 years.
Yeah.
Because they all know that flash disks are...
That's a brilliant question, and I'll answer that in 2 minutes if it's okay, please.
Okay.
Everyone asks that question, and I love it when people do, because that's the whole point of the company I work for, which is great.
Not on last, but they explain.
So, first of all, I'm just going to talk and answer this gentleman's question about persistency and that kind of thing. So, as I said, we are in the mould of an enterprise array, so we replace potentially usage of things like FreePARS, EMC, NetApp, etc. Yeah, and with that one box, obviously we don't have resilience like shelf-to-shelf resilience. We don't have multi-controllers, all of those kind of things that you would expect. So we have a product which is called Invicta, and this is very simply a pile of accellers with some routers sat on top to route the data. And we're using routers rather than controllers because controllers add latency. The Acceler has about 120 microseconds latency, which is by far going to be very much lower than anything you see in the disk world, because it's SSD. If we added controllers, traditional type of controllers on the front of that, which are doing caching locally and then writing those writes out to disk, we would add huge amounts of latency. This product has InfiniBand in the back end, and it ends up being 200 microseconds latency. So the latency is only a little bit slower because we're adding redundancy and all of that resilience around it. So very low latency.
Yes. The
And-
BGB is bits or bytes? Bytes, I assume.
Sorry, pardon?
You have the numbers. Sustained write 6 GB. The B is bytes?
No, it's
bytes.
Yeah.
Thank you.
I've got that. I'm going to have more detail about that in a minute as well, if I'm quick. So very simply, this box has dual controllers, and it currently scales to 72 terabytes. In the future, you're going to see far bigger scale with this box. And we also believe that from a cost point of view, whilst cost per IOP for us is very low, obviously cost per terabyte is going to be higher than many of our disk-based competition, which is fair. But we do believe in the next 12 to 24 months, you're going to see something very akin to what went on when we shifted from CRT to LCD screens. If you look at the quarter-by-quarter reports from Seagate and Western Digital, there's plenty of information that proves that their businesses are going in very much the wrong direction. The disk business is going very much downhill, and the SSD business, if we look at our suppliers, we're going in the other direction. So again, this has all of the standard connectivity. It does up to 650,000 I/O. In fact, actually, we launched some new software. Our new software, which we launched at SNW this week on Tuesday, has driven that to 800,000 IOPS. So we have even more performance bandwidth now, which is great. And yes, about 8 gigabytes per second now with our new software we're getting to, and still with 200 microseconds latency. So it's a very high performance product. And, you know, this product would be very suitable as a whole for persistent desktops, as has been discussed, but also for desktops in the range of 10 to 15,000 desktops in one box. Yeah? It all depends, obviously, on the kind of desktops you're serving out. If you're serving out very small, very basic Microsoft, Microsoft Office type users, you can get tons of desktops on here. But if you're hosting workstations and people who are doing complicated CAD/CAM, it's fewer. At VMworld and Citrix Synergy, yeah?
I did this as well quick because when I talk to customers, I talk about and compare Atlantis to spinning disk, but everybody knows spinning disk is dead, right? I mean, it's coughing its last. So there is a new paradigm coming. So whether it's shared SSD or local SSD or software or whatever, it doesn't matter. But what I feel I should be doing when I'm doing my presentations is comparing my products to maybe, V3 or Whiptail or something else like that, because I think that's much more relevant than comparing it to old school SAP.
Okay, but in the reality is when I'm talking to customers, the customers are looking to buy old school products at the moment. They're not really looking at many of these products. But anyway, I've only got 5 minutes left, so I need to kind of crack on, I'm afraid. The other thing that's very cool about this is that literally it's very cool in that we use very little power. So this whole array, this whole amount of performance, it's from 440 watts, but in total it's about 1400 watts if you go for the full configuration. And that's a really big difference to what we see when you look at, as you say, the traditional arrays. So that's the Invicta product. Now, the question that was asked was about how we deal with drives and will the drives fail, very simply. We're doing a really detailed session on SSD tomorrow where we're going to talk about our knowledge of SSD and how it works and all these kind of things. We're going to do this in a lot of detail, so I would really recommend you come to that session because it's not just about Whiptail, it's about just generic SSD and how it works. But very simply, if you look at SSD, when you write to it, in fact we're using consumer SSD, we're not using enterprise SSD. When you write to SSD, you're actually writing in blocks, yeah? So you'll have a block here which will have lots and lots of I/O on it. And every time you flash it, you're flashing the whole thing. So every I/O that goes to it, you're actually basically multiplying the I/O because you're having to flash a whole load of previously done I/O. So in a traditional disk system that doesn't, or a system that does not manage SSD, you end up multiplying the writes because you're constantly flashing these big cell groups, yeah? what we've done is we've developed software, and right at the core of our product is a thing called Race Run OS, which basically completely manages SSD. And what that means is that we hugely reduce the amount of flashes we actually do to disk. And we actually do that really cleverly without using very much cache or without using very much memory. These boxes that I'm talking about each have about 24 gig of RAM in them. They don't have hundreds and hundreds of gig of RAM in them. And most of that is for our operating system. The cache that we're using in terms of the in-memory cache in each box is 2 meg. It's tiny because we're getting the performance from the SSD.
You need 24 gigs just for an OS.
Yeah.
That's a pretty big OS.
Yeah.
Well, it's not. It's not just the OS that it handles. We actually build. So when we're doing things like the LBA to PBA table, that's held in memory and that's rebuilt into memory. So that's held there. That takes up some memory space as part of the OS, as part of the management of the drives. You've actually got 48 meg of buffering in there because we have eight 2 meg overlapping buffers and then some buffer overrun capacity in case there's some misalignment, something along those lines. And there's a whole bunch of stuff. It's not just 24 gig for the OS, it's 24 gig for a whole bunch of stuff that we do. The OS itself is actually very, very small. Minute number of lines of code for an OS, it's CentOS 6.2.34 as a base kernel, and some stuff on top of that. So really it's not that complex as an OS. Well, I say it's not complex as an OS, it's not complex as a base kernel. What we do on top of that, so it really doesn't take up that much memory, but you can't buy small amounts of memory now. It's nice to have a bit of extra.
Thanks, Mike. Yeah, so to give you a really...
It doesn't answer my question, because I know that this technology reuses the blocks intelligent-wise, but what I'm asking is, how long will it last then? So if I run 1,000 desktops on it, how long will it last?
So our product comes with a 7.5-year guarantee that it will last. Yes. And our oldest customer, who's 3.5 years old, we have if you look at the box, obviously once you bought one, obviously. No, I'm joking. If you look at the box, we actually have a gauge on the box which gives you an indication. Our oldest customer, who's 3.5 years old, the gauge is currently showing that they'll start to have issues in 18 years' time. Okay. So, and that's using, and that is literally like that. And we're using consumer grade flash, which is why we are. And actually, to come back to a question, I think you had around cost and dedupe. To be honest with you, for VDI especially, we have a great cost point right now. To be honest, I'm involved in I'm probably involved in like 20 opportunities at the moment, and 15 of them will be VDI opportunities because obviously that's where we're driving really high I/O. Yeah, that's the obvious place where this kind of product makes sense, but there are more and more other places. But from a cost point of view, we're really very strong because we're using consumer grade flash.
To give you a live example, we've got a 2,500 user VDI implementation as well, so it's even a bit heavier than Citrix and desktop. And that's currently showing 22.5 years is the expected drive life. Now, I don't know about you, but in 22.5 years I intend to have that not as my problem anymore.
We had a partner try and move the needle. In order to move it 3%, they had to put 4 petabytes of drives through the box.
And that was 4 petabytes through a 1.5 terabyte box. They did it in about a week, and they managed to move the needle a few percent.
And based on where we're seeing the pricing of traditional storage, we're seeing us bringing that cost point down about 70%. For the storage cost in a VDI deployment, 70% saving using Whiptail compared to traditional bits.
And we're also, and in answer to what was being brought up earlier, we're also finding we are competitive where we're bidding against new category products like ourselves as well. So I have 8 seconds there, which is quite scary. So I hope it's been really useful and it's been good. And as I say, we're here all weekend. We've got a few more sessions. Come and have a chat with us. And thanks very much for your time. Cheers.